Hello, chemistry students. This is Mrs. Altman, and I am here for a little Q and Mrs. A, just answering a couple of questions that I've gotten via email that are just better answered in a video format. For things that are easy for me to answer via email, I've put them all on a Google Doc, which are attached to, I think it's called Everybody Resources on Google Classroom, and I've just copied and pasted any questions that were emailed to me as well as my responses. But these are the questions that I just felt were better answered in a more spoken format. But before we get to that, we must do a shout out to our sponsor. So thank you very much, Ethan Rofe, for entering your name into a basket to get a shout out in this video. And on that vein, I wanted to actually discuss something that sometimes annoys me a little bit. So sometimes I'm grading lab reports and I see lab partners, Ethan Rofe. That's wrong. That's not how you spell his name. I'm going to show you how to actually get that letter. All right, so if you have a phone and you're typing, all you need to do is you hold down the E, hold it down for like 5-10 seconds, and then all of a sudden all of the accent marks will appear, and then you can just select that accent mark. If you've got a numpad on your keyboard like I do, you can just do Alt 0 2 3 3. Hold down Alt and then 0 2 3 3, and that'll get you the accent mark. You could also do Insert Special Character, and then you just type in E and it usually pops right up. Yeah. And then you can just press Insert, and then it should already be there. Actually, you don't even need to press Insert. So I've just given you 3 options. So you can either hold, if you're on a phone, hold down E, it'll pop right up. If you've got a numpad on your computer and it's Windows, Alt, and then 0 2 3 3, or you could do Insert Special Character. And then the letter E, and just click it. So Ethan, please send that to your lab partners so they should be spelling your name right from now on. All right, now on to chemistry. So the first question I got was about laws versus theories. This wasn't really asking for me to answer a question specifically like in a problem form, more just, can you please explain this a little bit further? So I'm going to use an example. So we have the theory of gravity. And I'm not going to get too much into what that means, but what we need to know about the theory of gravity is that all objects that have a mass exert some sort of force due to the fact that they have a mass. And there could be, more I could say about the theory of gravity. That's not really the purpose of this video. You might not already know this, but there's actually something that is sort of a law that relates to gravity. So it's called Newton's law of universal gravitation. And all that states, if I'm remembering this correctly, which also this is not necessarily the point of the video, is this equation right here. There's no explanation for it. So Newton's law of universal gravitation just gives us a mathematical formula that we can use to calculate the force. It gives us no explanation for why this works. Whereas the theory of gravity gives an explanation. So the big difference is that a theory has an explanation, and it's really an idea. So we can't prove these false because they're not really things that we can measure. They're concepts. Whereas Newton's law of universal gravitation, you can measure this. It's observable, or it's really a summary of observations. So a hypothesis can become a theory. That is assuming that that hypothesis has an explanation associated with it. Right, now, the second question that I got was with electron configurations as it relates to physical and chemical properties. So there was a question in the H study guide that a couple people were having trouble with. So let me take this electron configuration that I have. So let's say you were given this electron configuration and you were told that you need to list, let's say, 2 properties of this substance, and that you need to connect those properties to the electron configuration for the substance. So if you look at this, you could just go and find it on the periodic table. and you can see that it's zirconium. That's not really what that question was asking, though. What I'm seeing when I look at this electron configuration is that the valence electrons are in the S and D subshells. These electrons are very loosely held. So loosely held electrons lead to certain properties. So one of which is the ability to conduct electricity. The reason why that's a thing is because if you have loosely held electrons, electrons can easily travel from point A to point B. And what you need to have an electrical current is moving charged particles. The other thing that you could expect is you could expect for this to be shiny. So the reason why is you're going to have these moving charged particles are actually going to be reflecting light as they're moving. There's other things we could say about this in terms of like oxidation reduction reactions, but that's not really the point. Typically for questions like this, I'm really looking for loosely held electrons or tightly held electrons. Let's just say if there was something, for example, if I gave you now, if I gave you that right there, which you can see is neon, and I were to ask for you to tell me, I would probably just say one property of this. I would just say that it doesn't conduct electricity because electrons in the p subshell tend to be tightly held. There's not as many cohesive properties of things that have a lot of electrons in their p subshells as things that only have S and D. Right, and then the last one was somebody wanted me to do a sig fig with temperature conversions. This is HH only because those of you in the CP and those of you in the H class, you will just be able to round wherever you want. So we're going to take this value here. It's kind of similar to one of the ones in the problem set. We're going to convert this to degrees Celsius and to Kelvin. So first thing I'm going to do is I'm going to take it out of scientific notation. All right, so it's kind of showing up as looking like it's between the zeros, but it's not. So I've got 30,000 Kelvin, and I'm going to now be converting that to degrees Celsius. To do so, I'm just going to subtract 273. So when you first put this into your calculator, you're going to get 29,727. But I need to round that to the 1,000 place. So this 273, this is a constant. So I'm going to round to the most precise digit, which is this 0 on my least precise measurement, my only measurement, the 30,000. So this is actually going to be 30,000 degrees Celsius. So sometimes that will happen. It's only going to happen with really big numbers. Now we're going to go ahead and convert that to Fahrenheit. So we take my 1.8. First thing I'm going to do is just multiply 1.8 times 30,000. I'm going to round that to 2 sig figs. So that'll be 54,000 plus 32. When I do 54,000 plus 32, I'll originally get 54,032, but I need to round this to the 1,000 place again. So it's going to be 54,000 degrees Fahrenheit. All right, that is all I have for you. Good luck on your midterms. I'm sure you'll do great. All right, bye.